Welcome to our today's webinar. My name is Christine Odorfer, and I'm glad that you are here. I'm your host today, and we also want to welcome my colleague José Garrido, who will answer the question how to optimize your mass acute filling charges in batch centrifugals. So then, José, it's your turn.
Thank you so much, Christine. Thank you for having me again. Today, we have the topic to discuss how to optimize your mass acute filling charge in batch centrifugals. And this is, and I am especially happy today to discuss with you this topic because, in my opinion, and in BMA group opinion, this is one of the most unknown problems which are separating you to have a very good production level. And for that reason, it's very important under my point of view, this topic to be discussed and to be enlightened. For that reason, one of the most important goals for me today will be to show you how important is the optimizing the load of your centrifugal. And what could happen if I ask you direct this question? Why is it important to optimize the load of your centrifugal? So probably most of you could say me that there is a lot of potential to save valuable resources like water, like energy. And for that reason, then if I could optimize the load in my centrifugal, I could design more efficiency production and save energy, therefore save money and give you my production a boost. And that is absolutely right. And I promise you that could be my argument at the end of this presentation. But as I told you, this problematic is really unknown. And to give you some advice, we will discuss a little bit with some figures. So let us imagine that this glass is the basket of your centrifugal. And then you have, first of all, loaded with mass acute, and then you spin it, and then you give some water, and at this moment has a beautiful white sugar actually ready to discharge. But, and now comes, at this moment, it could be you are a little bit generous with the water, or let me say your centrifugal are manual operated, and then you give only 1 second more washing water in this beautiful white sugar ready to discharge. What happened then? Good, let's do some quick and easy calculations. Yes, I would assume that we have in the outlet of the washing water the nominal pressure, and that is 6 bars. That means that if I have 6 bars in my outlet in the cleaning section of the centrifuge, I am having a flow rate from 3 liters per second. In other words, in 1 second more washing water, I am adding 3 liters of water in my sugar. Let me assume that the temperature of the washing water are 70 degrees. Theoretically, this water temperature should be between 65 and 85 degrees Celsius. Let us assume 70 degrees of this washing water. The sugar solubility, the sugar solubility of water at 70 degrees Celsius is 323 grams per 100 milliliter. Or in other words, we are diluting 3.2 kilograms of ready to discharge sugar when we add 1 liter at 70 degrees. But as I told you, we have a flow rate of 3 liters per second. That means that in one charge, adding only 1 second more washing water, you are diluting in your basket, in your centrifuge, 9.7 kilograms of sugar. And now I will start to multiply. Let us assume that your centrifuge is running 24 cycles per hour. That means that you dilute 233 kilograms sugar per hour in the centrifuge. Again, sugar ready is to discharge. If you are running during the season, during the campaign, 23 hours per day, let me assume some cleaning cycles, some small delays because of interlocking and whatever, that means that per day you are diluting inside the basket for 5.36 tons of sugar. If you are running a season of 120 days, which is normal, and of course, people from Peru or from Colombia, which is running all year long, or people which are running a refinery, which are running 340 days per year, it's easy to calculate. But let us assume 120 days for one season. You are diluting in your centrifuge 643 tons of sugar, only when you add 1 second more that you need. Okay, but you can tell me, okay, Jose, hold on, sorry. Thank you. Okay, Jose, hold on. You are writing dilute, okay? I understand your first slice. That means I am adding more water and I am diluting, but I am recirculating. So at the end of the day, I will have the same amount of sugar in my pocket. Yes, you're right. You will have more energy cost. You will have a season longer because we are losing 650 tons per year in each centrifugal. But it is true that you will get all this sugar back in your pocket and a package in the dryer after the dryer and selling to the customer. Is that right? It is not. What you are saying right now is a very easy and right model of the crystallization made by Mr. Rosa. And in this paper named Sugar Crystallization, Look for the Devil in the Details. This paper was appeared in the International Sugar Journal in 2008. So I give you all this information so that you don't think, okay, that is sales arguments. No, we are reading from people from sugar, which are developing such models. And what says this model of Mr. Rosa? You can see that crystallization is having a win of 0.6. And of course, we have some recirculating. And on the top of this figure, which is taken directly from the paper, you have the product yield, 50.9%. That means that you pack in your crystallization station 1 ton and you get the sugar 50.9%. Or in other words, you are losing, no more diluting, losing 350 tons per year in each centrifuge when you are adding 1 second more washing water as you need. Wow, that's a problem. And now is the question, is there a solution? Yes, of course, is there a solution? For that reason, we are here right now. And the solution is right there, our machine, our e-machines. Why I am so sure to telling you something like that? Well, because this machine is equipped with a very sophisticated control system. And this control system is very good. And we are adding a lot of sensors all around the machine to have under control all the processes which happening inside the machine. And one of these sensors is this little body over there. And I am talking about this little body at this point. But what is that? Okay, this small sensor, the name of it is DINFAS FS, and DINFAS stands for Dynamic Factory Automation System. And FS stands for Feeling Sensor. That's the name, that's the introduction. What does this sensor do? Good. This sensor is a radar measurement which allows us to measuring the sugar layer thickness in real time during the load of the machine. This is very interesting because with this small sensor, we are solving a lot of problems. One of them is the basket overfilling, and it's very disgusting to cleaning all the machine when you have some overfilling in your centrifuge. Of course, the process will be adjusted continuously, and the filling rate is easily to do in the HMI in the software. Of course, we are controlling the addition of washing water in a half of the second in real time. And this is very important because with this sensor, with this technology, we are resolving the problem that we have shown, and a problem which probably we don't know yet. But many people of you will say, okay, Jose, we have this mechanical stroke hand, and actually it's more or less the same, right? No, it's not the same. Why not? Because the stroke hand is only active at the end of the loading process. So when you are adjusting it at 80%, 90%, and he say, okay, I'm ready. But what happened when in all the process before of that, you have no control? And the problem is when you are waiting for 80% of load, but you are getting 75 or 70, 50. I saw many cases in this way in many sugar mills. So for that reason, I told you this is not the same, and it's not the same possibility, the same functionality. And we have saw already how important 1 second of washing water is. Only 1 second. Okay. How does it work, this small sensor, this DINFAS FS? Good. Let me show you more or less. Of course, I cannot explain perfectly because I am not the automation engineer who program all this sophisticated control loop, but I can give you some advice. This control system, the PLC, what we are using in our centrifugals, are getting not only information for the DINFAS FS, are getting information all around the machine and in other points of the process. For example, we are getting some information about the level in the mixer, because with this information and a little bit software capabilities, we are modifying the time and the grade of the feeding valve and measuring automatically the layer thickness so that we can go for each cyclus, for each batch, to 95% of the basket capability. And if it is not possible, because for example, the level is so slow and we don't have enough gravitatory pressure, then we will adapt automatically the amount of washing water according to the level of the basket, the filling level of the basket. What you are saying right now is the easily set point of this sensor. We are showing you the new control system that we have. It is 2 years old, relative new, and it's the E Series 3, and it's very easy to set up. you have to set only a couple of breakpoints or switch points to adjust the amount of mass acute that you want to get in your basket, in your centrifuge, and we have some control behavior algorithms inside, because with experience, we have realized, we had found out that you guys are running the fabrics in very different ways. There are customers, there are sugar mills which are working very smoothly. And I mean that the crystallization station is always giving mass acute so that the level sensor in the mixer is more or less always the same. That is for the centrifugal, very smooth behavior. But there are other customers which are working in other ways. For example, they are producing one batch in a crystallizer, and we get on our mixer, I don't know, 80 tons of mass acute, which are processed very fast through the bank of the centrifugals, and we are running the mixer till the end. And after that come another batch of the crystallizers, another 80 tons, and that means that this level difference is a very hard conditions for our control loop. For that reason, we need to define different behavior of our algorithm so that the machine can adapt automatically at this way to run the fabric. The next question is if this sensor, this DIMFAS FS, does really work. Does it really work? And to answer this question, I won't be myself answering you. I will show you how it's happening in one centrifugal. You know exactly what smart monitoring is because Christine had made a beautiful webinar regarding this topic. It's our Industry 4.0 platform where you can, thanks to that, you can monitoring your centrifugal every time, everywhere from your computer or from your mobile phone. And what we are saying here right now is the behavior of one of these centrifugal in real time. So as if you can see, we have always the point of filling over 90%. So that is another difference. You will have the certainty that your machine is running 90%, not like with this mechanical end socket where you don't know exactly what is the filling level that you have. You will have always over 90% real filling level, and repeatedly, all the time, all the day, your production will be very efficient. And if we don't have 90, we have 92 or 86 or 70, the wastewater, the amount of wastewater will be automatically and in real time adjust. I like this slides as well, because if you see, you have here some peaks, this peaks and this peak and this peak, which are repeatedly after 5 cycles from the centrifuge. That means only that those guys are using a cleaning of the sensor, and a special cleaning, maybe 30 seconds, it's 5 cycles. So you can see it's very easy to configure the sensor. It works really, and I think it's really amazing what my colleagues from automation is making regarding the control system. The availability of this sensor is, of course, a series in the E-series is coming always by default, because as I told you, we think in BMA Group that this problematic of the optimization of the mass acute filling charts are critical. For that reason, for the A-series is always this sensor mounted. For the old machines, the B machines, the G machines, we have the possibility to get this sensor as well in an upgrade kit, or as I presented a couple of months ago, we made a webinar regarding the retrofits of VATS centrifugals so that you get all the sensor, all the capabilities, all the new control sensor, the new control system that we have for the edge centrifugals in the old ones. Wow. I am almost done for today, and I come back with the question how to optimize your mass acute filling charge. And the answer for this question is pretty simple. Given the trust and the BMA technology, we have the answer for this problem. And if you do in this way, you can save, as we learned, more than 300 tons per year and centrifuge if you are right now adding 1 second more. So it's really expensive not to use this technology in your centrifugals. And of course, because we are not diluting so many sugar and we are not recirculating so many sugar, your season, your campaign will be shorter and effective. That means you will save more money in normal cost because your campaign will be shorter. You will save more money because of the energy, and you give the production a boost, and you will get the production that you need and you deserve. And that was everything from my side. Thank you so much.
Thank you so much, José, for this presentation. I think we can jump right now into the Q&A part, and we do have some questions for you. So let's start with the first one. Is the DINFAS FS usable in cane and beet factories?
Yes, it is. It is. Of course, sometimes the mass acute level and the chemical characteristic of the mass acute is a little bit different in some fabrics. But for example, the graphic that I showed you, that was taken from a sugarcane fabric. And yes, it is working properly. So for beet, for cane, and of course for refineries as well. Yes.
Thank you. So then let's switch to the next one. One part of this question you already answered because it was asked if the sensors can be used in old machines too. And the second part is if it can be used in machines that are non-BMA equipment.
With our old machines, it is possible to use this sensor. As we present a couple of months ago, we have a very nice retrofit program so that you get all this control system, the new control system, the standard that we have mounted in your old centrifugals. And regarding other producers, no, it's not possible because it's a unique know-how that we have get with a lot of study and a lot of research, and for that reason it's only available for BMA machines.
Okay, thank you. The next one, if I buy the DINFAS FS, can I install it on my own in my machines, or do I need a BMA service technician to do it?
So theoretically, you can do that if you have some knowledge of the control system and so on. But I wouldn't recommend it to go in this way, because as you see, you need a little bit feeling with this sensor, and for that reason, in the commissioning of this of the sensor of the machine, our technician will teach how to go with this machine and making a suitable setup of the machine with the cleaning cycles, and it's better to be installed from a professional of BMA.
Okay, so we are right now in a COVID situation where we cannot travel. It's not possible to go to some countries. Therefore, we also have the remote services. So if you do need any support installing the DINFAS FS, our service technicians are there and can help you also with our remote software. So then let's switch to the next one. The mechanical charging sensor is running good in our factory, and we think there is no difference.
Okay, I don't know. It's a little bit. It's a very good remark from you, because those losses that you are having in your machine, you are not seeing at all, because of course you are giving a little bit more water. And as I told you, the mechanical feeling is giving you an advice at the end of the loading. But what happening really, it's you don't know. You cannot know it, because this sensor is a mechanical one. It is only responsible for one point. Our measuring is running all the process, and it's giving you information in real time. So we can sit together and discuss, and we can see it.
Just write us an email on sales@bma-de.com, and then we can have some further discussions on this topic. Then let's switch to the next one. What was the switch point in the filling cycle that was referred to on the HMI screen?
Yes, that was a simple word, as an example. I think it's 35%. It's not a big deal. It depending this switch point of the distance between your mixer and your centrifuge, and of course it's depending of the chemical characteristic of your massicute. For example, if you have a massicute very liquid, then you need a set point different, as is you have a massicute with higher density. It's better to go and make the setup directly with you guys and showing how are the parameters that you can change and you can see, so that at the end of the day you understand how this sensor works.
I think there was a little comment to this question before, because somebody told us that adding the wash water is not automatically in their site. So maybe they have some problems that they have to install something, stuff like that. If you need further questions, just write us an email. I think it's the easiest way to discuss topics from your factory, from your site, and then we will answer them right away. Then there's the question for the budget, but please be aware that we are not able to share any numbers right here, because there are many factors on the price that go in. So if you have a case for us where you want to install the DINFAS FS, write us an email, as I said before. We will talk to you, get the figures of the machine, and then we can give you a quotation for the DINFAS 2. Okay, so then there is a question. What happens when it reaches the switch point, in addition to your explanation? Okay,
you get the switch point and you close the feeding valve. Okay. And we set the switch point at this level, because of course between this valve and the basket you have differences. You have a big pipe, and this pipe is full of massicute. So what you are doing is breaking out the valve, so you are closing the valve. But of course what we are doing is playing with the time, playing with the angle. It's as I told you, it's a sophisticated control loop. What can I say? It was made for a good friend of mine, and I know him, and I know how much know-how he has, and for that reason, it's pretty brilliant, I have to say.
Okay, yeah, the suggestion was made in the chat too with the valve, so I think the explanation was good. Then let's come to the last question I saw in the chat. You have shown smart monitoring in your slides where they can see the filling level of the centrifuges. Is it always included in the Dünfas when they buy it, or do they have to buy it separately?
With the Dünfas is not included, but normally, for example, in the retrofit. So there are different ways to make a retrofit. If you purchase a retrofit, for me, is changing the whole control system. So we make a new control cabinet for your centrifuge. Then it's normally included the smart monitoring, because we think it's a very good tool to control the production all everywhere, and give you some advice what is really happening in this machine. That is again what we have heard. Many people say, no, it's in my production is working properly, but actually you are not knowing. And like the paper of this Mr. Rosa says, is the devil is in the details, and only 1 second can make you lose a lot of money. For that reason, it's always we are in the 21st century, the time is changing and everything is connected, and of course the centrifuge needs a good brain to produce the best sugar that you can.
Thank you. I got the sign that we have time for one last question, so I will tell them right away. If we use the system, will it adjust the thickness automatically or only pulls to filling valves?
Could you repeat that? I didn't go.
Yeah. If we use the system, will it adjust the thickness automatically or only pulls to filling valve?
I don't know if I understand 100% what your question is. And again, I think my email address and everything is all over the world. Please write me an email and we discuss. I love this discussion, so it's not a big deal. So what we do with this system is to optimize this filling level. So you will say, okay, at this point I want to have 90% of the filling of the basket full of massacute. That is your point where you will say the control system 90%, 95%. That is the point that you say, and the machine will adapt his behavior according to all the variables that we have saw to help you to achieve this 95%. And it can be done, yes.
Okay, thank you so much. So thank you so much, dear listeners, for joining us today to our webinar. Thank you, Jose, for this great presentation and answering all the questions. If you do need any more information, write us an email, write us on Instagram, and especially give us a like on our YouTube videos. So then let's see you next time. Stay healthy and goodbye.
Goodbye.